All right, welcome to lesson 3.1, rational numbers and decimals. Excuse me, today we're going to work on converting a rational number to a decimal using long division. And then we're going to identify terminating decimals and repeating decimals. So you should have gone through and done your vocabulary already. Make sure that you know what each of those things are. So that way going through this lesson, it's a little easier knowing what we're working with. All right? So to start off, we're going to look at describing decimal forms of rational numbers. Okay, so again, those rational numbers, we need to make sure we know what those are. They could go on forever. If they do, they repeat. If they go on forever and don't repeat, they're not rational. And if they terminate, they're rational. Okay, so what we can do is we can actually take fractions and turn them into decimals. Now you have to remember, a fraction is actually a division problem. So in this case, 1/4 actually means 1 divided by 4. So if I actually take my calculator, and I'm going to go ahead and get my calculator out here because it says that I can use it right now. Okay, and move it over here. And I do 1 divided by, oh, nope, that's the plus sign. There we go, 1 divided by 4. That's a little better. I get 0 and 25/100ths. Okay, so this makes sense. If I'm taking one piece of something, so here's my one big piece, and I divide it 4 times, 1, 2, 3, 4. Okay, each of these is no longer a whole piece. It's 1/4 of a piece. Well, think of a dollar. When we do that to a dollar, each of these 4 pieces becomes 25 cents. Okay, so in this case, the the decimal equivalent to 1/4 is 0 and 25/100ths. Again, 5/8 would be 5 divided by 8, which gives us 0 and 625 thousandths. 2/3 is 2 divided by 3. Now notice, and this I wanted us to be careful with, calculators can't go on forever. So you'll see here that you have this 7. It doesn't miraculously turn to a 7 after having all of those 6s. Your calculator has to round up. So because of the fact that the next number is a 6, the 6 tells the other 6 to go up to a 7. This here implies that the decimal is repeating, so it is 0 and 6/10 repeating. It goes on forever. Okay, so here we have 2 divided by, oops, we already did 2 divided by 3, 2 divided by 9. And I get, so now here, notice it doesn't round it up because 2 wouldn't round up, it would stay the same. But in this case, this would be 0 and 2/10 repeating. Now 12/5. 12/5 is an improper fraction. Since it's improper, that number on top, remember the number on top tells us how many pieces we have. The number on bottom tells us how many go in each group. So if I have 12 pieces and 5 go into a group, it makes sense that I should have a full group or of one or, I should have one or more full groups. So when I do 12 divided by 5, you're going to notice that I get this whole number out in front of the decimal. Well, it makes sense that I can make 2 groups of 5, and then I have a couple of pieces left over. So in this case, my answer is 2 and 4/10. Okay, so then now, if you look at the last 2, so now we're going backwards and we're going from the fraction or the decimal to the fraction. Well, this is where you have to know your place values. So in this case, 2 is in the 10ths place. So this is 0 and 2/10. So what that looks like as a fraction is 0 and 2/10. But now it also tells us that we want to put it in simplest form. So I know that both of these can be divided by 2. So this is actually 1/5. Now because this is a 0, I don't have to put that in front. That's just extra. But what I want you to understand is the 0 is in front of the decimal to tell you that there are no whole numbers. With a fraction, it doesn't have to be there, but with a decimal, it does. Okay, so in this case, the fraction equivalent of 2/10 is 1/5. Now, could we say that it's also 2/10? Absolutely. We could also say that 4/20 is equivalent to 2/10. But we wanted it in simplest form, so we made it 1/5. Now we have 875 and it ends in the thousandths place. So I have 875 over 1,000. Well, in this case, they end in a 0 and a 5, so I can divide them by 5, but I actually know that 75 should be divisible by 25 and 1,000 should be divisible by 25, so I'm going to try that first to try to go a little faster. Okay, and when I do 875, so 875 divided by 25, I get 35. And then when I do 1,000 divided by 25, I get 400. Now in this case, I know that that is not simplest form. I can divide them both again by 5, and I get 7. I know 5 goes into 40 8 times with that 0 left over. So in this case, it would be 7/80. I'm sorry, I think I did that. That doesn't look right. 875. Then 1,000. I think I missed a 0. There we go. That looks a little bit better. Okay, this shouldn't be 400. This should be 40. I added too many zeros. Now if I divide them both by 5, I get 7/8. That makes more sense. Okay, now notice you'll see kind of a little pattern here. When I had eighths before, I got 625. And when I had eighths over here, I had 875. Every time you see eighths in the denominator, you know that it is going to be a terminating decimal, meaning it's going to end, and it's going to go 3 place values. Anytime you see fourths, you can think of quarters. So 1/4 would be 25 cents or 25 hundredths. 2/4 would be 50 cents or 5/10, and so on and so forth. Okay? So now here, what do you notice about the digits after the decimal point in the decimal forms of the fractions? Okay, so what do we notice about this? So you should notice that they either repeat or terminate. So they repeat or terminate. Okay, so in this case, this sign here means that it is a repeating decimal. These are all rational numbers, okay? So since they're all rational numbers, they all have to repeat or terminate, otherwise they are not rational numbers. Okay, so now here, we're going to look at this decimal that goes on and on forever. To know that it goes on and on forever, you see that these little dots here are here at the end, the ellipses, and it tells you that it goes on forever. Do you think this decimal represents a rational number? Why or why not? Well, remember, to be rational, it has to repeat, so it has to have a pattern, or it has to terminate. And terminate means it stops. Well, obviously it doesn't terminate, so we have to see if it repeats. Well, let's look at the pattern here. The pattern here, so we have 0, 1, 1, or I'm sorry, 1, 0, 1. It doesn't go 1, 0, 1, so that's not a pattern. It goes 1, 0, 1, 0, 0, 1. That's not a pattern. 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1. So if you're looking here, there's no form of a pattern. Since there's no form of a pattern, it can't be a repeating decimal. It has to have a pattern in order to repeat. So in order for it to be rational, it has to be one of those two. So no, it is not rational because it does not terminate or have a pattern that repeats. Okay, so then now let's look at number 2. Do you think a negative sign affects whether or not a number is a rational number? Okay, well, the rational number has to repeat or terminate. So does it matter if it's positive or negative? So in this case, 8/5, negative 8/5. Well, positive 8/5 would be equal to 1 3/5, which as a decimal would be equal to 1 6/10. Well, now if it's negative, does that change this at all? Outside of changing it to a negative 1 6/10, it doesn't change the fact that it still makes one whole group with 3 extra pieces. All it changes is the fact that now it's no longer positive, it's negative. And rational numbers do not have it cannot be negative or it cannot be positive. They can be positive, they can be negative. The tell-all here comes from the decimals, okay? It has to repeat or terminate. In this case, it terminates, so it is rational. So having a negative sign doesn't impact whether or not it's a rational number. Okay? So no negative signs do not impact, that's a P, whether or not the number is rational. Okay? So again, rational numbers have to terminate or repeat. Terminating means even if it's just a 1, it terminates at that 0, so it is a rational number. So here, do you think a mixed number is a rational number? Why or why not? Okay, so looking at this, looking at this, a mixed number, well, we just had the mixed number of negative 8/5. So mixed numbers can be rational because they can turn into, it can be turned into a fraction that terminates, or a decimal that terminates or repeats. So we can say a mixed number is a rational number because it can be written as an improper fraction, which is a ratio of 2 integers. So getting all technical here with this, I don't think that's going to help. If you look at it, you'll notice that, so like 22/7. Okay, 22/7 is a mixed, or is an improper fraction. Okay, now, it can also be turned into 3 1/7. Now, if you actually look at my calculator, get that back here. If I do 1 divided by 7, okay, I get 0.142857. Okay, so this does end. Okay, so because of the fact that it does technically end, it would be considered, or it could be considered a rational number. Now, here's the thing. It looks like it ends because of the calculator. All numbers on a calculator look like they're going to be rational. In this case, I actually know that 22/7 is an irrational number because it goes on forever. Okay, it doesn't repeat, it just goes on and goes on. So like actually if I do this and show you 22 divided by 7, you'll recognize this number here kind of looks like pi. Well, it is pi, and pi goes on forever, making it irrational. So this mixed number here, even though it might have looked like it was rational, is not. So you have to be careful with your calculator and know that, okay, my calculator doesn't always tell me the truth. This is why we have to use the long division. Now, mixed numbers. Some are going to be rational and some can be irrational. Okay? So in this case, this one would be irrational, but that 8/5 that we said turns into 1 6/10, that's rational. Okay? So I would say, instead of with their answer, I would say, do you think a mixed number is a rational number? Some are rational, and some may not be. Okay, so there is not an end-all be-all in terms of mixed numbers. So looking at how to write a rational number as a decimal, the example is already put out there for you. Again, you have to remember that this actually means 5 divided by 16. When you set up your problem as long division, remember that 5 has to go on the inside and the 16 goes on the outside. Okay, so even though technically we like to do this, if it's set up the same way as our division problem is, our long division is set up incorrectly. So no, this is incorrect. Remember, you have to flip your numbers. So 5 is on the inside and 16 is on the outside. Well, I know 16 can't go into 5, so that's where I have to put that 0. In order to add zeros afterwards, though, I have to add that decimal. And once I add the decimal, I'm going to bring it straight up and add it here. And now I can add this 0 and say, okay, how many times does 16 go into 50? Well, 16 goes into 50 3 times. 3 times 16 is 48. I subtract and I get 2, and then I bring down my 0. And then I continue to divide as normal, adding zeros until I get to 0 or I recognize a pattern, or I see that it is going to go on forever. So in this case, I notice that I get down to 0, so this decimal is going to end, it's going to terminate, so I know that this is a rational number. We are going to practice this a lot because long division is tough, especially when we're starting to divide smaller numbers by larger numbers. Okay, so looking at 13 33rds. Again, 13 on the inside, 33 on the outside. 33 can't go into 13. Look at it this way. I need 33 to make a whole group, and I only have 13. That's not going to work. So in order to make this work, I can't use whole pieces. I have to use tiny little cut up pieces. So in this case, I do all of my long division. And once I do my long division, I notice that, so I did 33 goes into 130 3 times, and I get 99. And then when I subtract, I get 13 left over. Add the 0, bring it down, I get 99. Okay, subtract, bring down the 0. And I notice, well, I get a repeating pattern. So it goes in 3 times, and then 9, and then 3, and then 9. Well, look at this. Once again, I end up with that 13 left over, and I would add a 0 and bring it down, and I get that 130. So that tells me that this is a decimal that's going to repeat. So now I don't write these added pieces here. I just show the first part of the pattern, and then I put my repeating symbol on top. Okay, so let's try and give this a shot. If you feel like you're ready to do this on your own, go ahead and come back and check your answers. Otherwise, go over it with me. So again, this is 4 divided by 7. If you want to look at it one way, what you can do is you can look at it as the fraction tips over, and 4 would fall on the inside, and 7 would fall on the outside, with this right here being your fraction bar. I know I cannot make groups of 7 with only 4 pieces, so I'm going to add my decimal and bring my decimal straight up. Now this is where being very clean with your work is really important. So I have to add my 0 here because it goes in 0 times, and now I can add this extra 0 after the decimal. So 7 goes into 40 5 times. 7 times 5 is 35. When I subtract, I get 5. Now I can add another 0. I can add zeros all day long if I want to. Okay? I add that 0 and bring it down, and I know 7 goes into 50. How many times? It goes into 50 7 7 times. 7 times. So 7 times 7 is 49. 50 minus 49 is 1. Again, I add another 0. Bring it down, and I get 10. And how many times does 7 go into 10? Well, it goes in once. Minus 7, I get 3. Add another 0. How many times does 7 go into 30? Well, it goes in 4 times. Minus 28 gets me 2. Okay, and then I would add another 0 and bring it down. Another 0, bring it down. Okay, 7 goes into 20. How many times? 2. Oops, I forgot to change my color there. Sorry about that. Goes into it 2 times. Minus 14 gives me 6. Okay, add another 0. Bring it down. How many times does 7 go into 60? Well, this is getting fun. Goes in 8 times. Okay, and then 60 minus, and I'm going to come over here because I've run out of space. Gives me 4. Add another 0. Bring it down. 7 goes into 40. How many times? Well, it goes into it 5 times. Minus 35. Well, now look it. Doesn't that look just like what we did here? And we get 5. Well, then isn't all of this process going to be the same? Since it's going to be the same, I know that the answer to this question is, right, 0. Okay, and that it is going to repeat. Okay, and then since it repeats, I put my line on top. All right, now that I've sufficiently run out of space on here, I'm going to go ahead and clear it off. And we are going to change 1/3 into a decimal. So 3 goes on the outside, 1 goes on the inside. I know 3 cannot go into 1, so I have to add my decimal, so I can add a 0. If I add the decimal on the inside, I have to add it on the top. Now I can add my 0. 3 goes into 10 3 times. 3 times 3 is 9. Well, I'm going to keep adding these zeros and getting 10. 3 is always going to go into 10 3 times. So what I should notice right away is that this is going to repeat. And it is going to be 0 and 3/10 repeating. Okay, once you notice a pattern, and you might want to do it a couple of times just to double check, but once you notice that it's a pattern, you can stop and show that it is a repeating decimal by using that line on top. Okay, and then again, you have 20 on the outside, 9 on the inside, 20 cannot go into 9, so I have to put my 0, add my decimal, add my decimal. Now I can add that extra 0. 20 goes into 90 4 times. I subtract 80, and I get 10. I can add another 0 and bring it down. Well, this is quite nice, because 20 goes into 100 5 times. 5 times 20 is 100. So in this case, I get to 0, and this one actually terminates. So this one is actually just 0 and 45 hundredths. So yes, is this process lengthy? Yes, it is. But the reason you can't use a calculator is because your calculator is always going to show that it terminates, because obviously the screen doesn't go on forever. So that's where this long division comes in. All right. Okay, the next part of your notes shows you an example of converting mixed numbers to decimals. I'm not going to go through that with you because it's really just the same thing. You're taking your fraction and converting it to a decimal, and then this whole number just goes in front of the decimal, right? So, for example, on this your turn, if you want to try it on your own, go ahead. But here, I know that I'm going to have a decimal, and that 2 is going to go in front because it's a whole number. And then what I'm going to do is I'm going to take my 3 and I'm going to divide it by 4. I know it's going to go 0 times. I'm going to add my decimal and add my decimal. Add my 0. 4 goes into 30 7 times. Minus 28 gives me 2. Add my 0, bring it down. 4 goes into 20 5 times. Minus 20 gives me 0. So I know that 3/4 is equal to 0 and 75/100. But there's a 2 in front of it now. So instead of 0 and 75/100, 2 and 3/4 is going to be equal to 2. So this 2 comes here, and then this 3/4 turns into the 75/100. In this case, it doesn't go on forever with a pattern, so it is a terminating decimal. Okay, and then now what I'd like you to do is I would like you to try number 8 on your own and then come back and check your answer. All right, what you should have found is you should have found that you would have 7 in the front because that's your whole number. So that's always going to go in front of your decimal. And then if you take 3 and divide it, or 1 and divide it by 3, 3 goes into 1. Well, it can't, so I have to add that decimal. Okay, 3 goes into 10 9 times. I'm sorry, 3 goes into 10 3 times, getting you a 9. See, we all can make those mistakes. We just got to slow down and catch it. I'm trying to go too fast. 3 times 3 gives us 9. There we go, and we get 1. Well, we saw this before. We're going to bring down the 0 and get 10. Okay, and it's going to go in 3 times. We're going to get 9. So I'm not going to lie, 1/3, you should be able to look at 1/3 and always know that 1/3 is going to equal 0 and 3/10 repeating. And if it equals 0 and 3/10 repeating, then 7 and 1/3 should equal 7 and 3/10 repeating. And then in this case, I'm going to do a bunch of erasing here so we can actually see what's going on. There we go. Sorry about that. And in this case, you should see that it is a repeating decimal. So since it's repeating, it is a rational number. All right, and then what you're going to do next, you have your guided practice problems that I want you to complete. Right? Take your time, show all of your work on a separate sheet of paper for your long division. Give yourself lots of space. You might need multiple sheets of paper. Again, take your time, practice, go slow. As you saw, I sped up and made quite a few mistakes, so make sure you're slowing down. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.